Something extraordinary is happening in laboratories around the world that will forever change how we deal with toxic waste. Can you imagine microscopic organisms literally eating batteries and turning deadly poison into harmless materials? Well, scientists have just achieved it. While some countries are still burying millions of tons of battery waste in landfills that will poison our planet for centuries, researchers have discovered bacteria that seem straight out of science fiction. From microorganisms that can digest heavy metals to biological machines capable of extracting valuable materials worth billions of dollars. Today, I'm going to show you the 8 most incredible battery-eating bacteria discoveries that are completely redefining the future of recycling. Stay until the end, because what you'll see at number 1 will undoubtedly leave you speechless. But first, let me tell you why this matters more than you think. Right now, at this very moment, there are over 15 billion dead batteries sitting in landfills worldwide. These batteries contain toxic heavy metals like lead, cadmium, mercury, and lithium that are slowly leaking into our soil and water supply. A single battery can contaminate 600,000 liters of water. That's enough water for one person to drink for their entire lifetime, poisoned by just one battery. The traditional recycling methods are expensive, energy-intensive, and still leave behind toxic residue. But nature, as always, has found a solution that humans never imagined possible. Number 8. Acidithiobacillus ferrooxidans, the metal extractor. We start with something that has just completely changed the rules of battery recycling. Acidithiobacillus ferrooxidans is a bacteria that thrives in extremely acidic environments, and it has an incredible superpower. It can literally eat through battery casings and extract valuable metals like copper, zinc, and cobalt. To give you an idea, traditional battery recycling requires heating materials to over 1,000 degrees Celsius, consuming massive amounts of energy. This bacteria does the same job at room temperature, using nothing but its natural metabolism. How is such efficiency possible? The key is that this bacteria produces sulfuric acid as a byproduct of its metabolism. This acid dissolves the metal compounds in batteries, releasing the valuable materials inside. It's like having millions of tiny miners working 24/7, extracting precious metals without any machinery, without any pollution, and without any energy costs. Scientists at the University of Edinburgh discovered that these bacteria can recover up to 95% of the metals from lithium-ion batteries in just 2 weeks. What's most impressive is that the bacteria actually prefer the toxic environment inside batteries. While these conditions would kill almost any other living organism, Acidithiobacillus ferrooxidans thrives in them. Number 7. Shewanella oneidensis, the electron thief. In 7th place, we have something truly mind-blowing. Shewanella oneidensis is a bacteria that doesn't just break down batteries, it actually steals electrons directly from metal compounds. This monster can reduce toxic heavy metals like chromium and uranium into less harmful forms, and it does this through a process called extracellular electron transfer. Imagine this: while other bacteria need oxygen to survive, Shewanella oneidensis can breathe metals. It literally uses metal compounds the same way you and I use oxygen. Its most striking feature is something you'd never expect in a microscopic organism. It has tiny hair-like structures called nanowires that conduct electricity. These nanowires allow the bacteria to transfer electrons over relatively long distances, creating what scientists call a microbial fuel cell. Researchers at the Pacific Northwest National Laboratory discovered that these bacteria can process battery waste while simultaneously generating electricity. You read that right. They're cleaning up toxic waste and producing power at the same time. The bacteria showed the world that nature's solutions are often more elegant than anything humans can engineer. With capabilities that compete with our best technology and an efficiency that surpasses them all, Shewanella oneidensis announced that the future of waste management might be biological, not mechanical. Number 6. Cupriavidus metallidurans, the heavy metal survivor. In 6th place, we have something that marked a before and after in our understanding of bacterial resistance. Cupriavidus metallidurans was discovered living in toxic waste sites, thriving in conditions that would instantly kill any other organism. This bacteria can survive concentrations of heavy metals that are thousands of times higher than what would be lethal to humans. But here's what's truly crazy about this bacteria. It doesn't just survive in toxic environments, it actually needs them. While other organisms flee from heavy metals, Cupriavidus metallidurans seeks them out. Its dragon-like resilience isn't just bacterial toughness, it's pure evolutionary engineering applied to perfection. This bacteria has developed specialized proteins that can bind to toxic metals and safely store them inside cellular compartments. Scientists at the University of Zurich achieved something that seemed impossible. They engineered this bacteria to not only store heavy metals, but to transform them into less toxic forms. The bacteria can process lead from old car batteries and convert it into compounds that can be safely disposed of or even reused. This bacteria showed the world that evolution had already solved the problem of toxic waste millions of years before humans even created batteries. Number 5. Geobacter sulfurreducens, the nanowire network. Geobacter sulfurreducens isn't just a bacteria, it's a lesson in natural engineering that has left the entire scientific world speechless. This legendary microorganism can form vast networks of conductive nanowires, creating what scientists call a bacterial electrical grid. These networks can span several centimeters, which in the bacterial world is like building a highway system across an entire continent. But its true power isn't just in creating networks, but in something no other organism has managed to equal: its ability to work collectively. The bacteria communicate with each other through electrical signals, coordinating their efforts to break down complex battery materials. It's perfectly designed to function like a distributed computer system, with each bacterial cell acting as a processing unit. When researchers at the University of Massachusetts discovered this, they realized they weren't just looking at bacteria, they were looking at a biological supercomputer. The maintenance is so sophisticated that the bacteria can adapt their network structure based on the type of waste they're processing. What's most impressive is that Geobacter sulfurreducens uses a biofilm formation so efficient that it can coat entire battery electrodes, breaking them down from the inside out. When other countries try to build better recycling systems, they're not just competing with bacterial efficiency, they're competing with millions of years of evolutionary perfection. Number 4. Desulfovibrio desulfuricans, the sulfate reducer. We reach 4th place with Desulfovibrio desulfuricans, a bacteria that maintains the reputation of microorganisms that thrive without oxygen. This beast can break down sulfate compounds found in many battery types, and it does this in completely anaerobic conditions. Its real secret isn't in pure decomposition ability, but in something revolutionary: it can neutralize battery acid. The bacteria uses a process called dissimilatory sulfate reduction that allows it to convert harmful sulfuric acid into hydrogen sulfide, which can then be further processed into harmless compounds. What makes Desulfovibrio unique is its ability to work in the harshest conditions. It can function in pH levels as low as 4, which is more acidic than orange juice. Its active metabolism allows it to process battery waste at speeds that would make traditional chemical methods seem slow. The result is impressive. Researchers in China built a bioreactor using these bacteria that can process 500 kilograms of battery waste per day, operating at ambient temperature with minimal energy input. This bacteria demonstrates that the combination of intelligent metabolic design, extreme environmental tolerance, and efficient waste processing can create an exceptionally effective recycling system. Number 3. Pseudomonas putida, the plastic and metal hybrid processor. In 3rd place, we have Pseudomonas putida, a bacteria that reaches incredible versatility in waste processing. This bacteria can break down not only the metal components of batteries, but also the plastic casings that surround them. What's revolutionary is that it produces enzymes that can degrade both organic and inorganic materials simultaneously. Modern batteries aren't just metal, they're complex composites of plastics, metals, and chemical electrolytes. Traditional recycling has to separate these materials first, which is expensive and time-consuming. Pseudomonas putida doesn't care. It attacks everything at once. Its construction uses specialized enzyme systems that can switch between different metabolic pathways depending on what material it encounters. This allows it to adapt in real time to the complex mixture of materials in battery waste. Scientists at the Technical University of Denmark demonstrated that these bacteria can reduce the volume of battery waste by 60% in just 30 days, breaking down materials that would otherwise sit in landfills for centuries. Number 2. Bacillus subtilis, the biofilm engineer. In second place, we have Bacillus subtilis, a bacteria that is changing waste processing with its incredible ability to form structured biofilms. This bacteria reaches speeds of reproduction that allow it to colonize battery waste surfaces in just hours, and it operates with an efficiency that impresses engineers across the scientific community. What makes Bacillus subtilis unique is its ability to produce biosurfactants, natural compounds that act like soap, helping to break apart battery materials and make metals more accessible for extraction. Its design without traditional chemical requirements means it can work using only the nutrients found in the waste itself. This allows it to be self-sustaining, requiring no external inputs once the process begins. The advanced biofilm structure eliminates practically all need for mechanical stirring or mixing, creating a passive treatment system that works continuously. Bacillus subtilis demonstrates that the combination of rapid colonization, biosurfactant production, and self-sustaining metabolism can create an exceptionally efficient and cost-effective waste processing system. Number 1. The engineered consortium. Nature's perfect team. Meet the future of battery recycling. Not a single bacteria, but an engineered team of multiple species working together in perfect harmony. Scientists at MIT have created a bacterial consortium that combines the best abilities of all the bacteria we've discussed. This technological marvel uses Acidithiobacillus to dissolve metals, Shewanella to generate electricity, Geobacter to form conductive networks, and Pseudomonas to break down plastics, all working simultaneously in a single bioreactor. The consortium uses extraordinary coordination, with different bacterial species handling different aspects of battery breakdown in a perfectly orchestrated sequence. Its most striking feature is its ability to process any type of battery, from old lead-acid car batteries to modern lithium-ion smartphone batteries, without any modifications to the system. What's revolutionary is that this consortium can recover 99% of valuable materials from batteries, compared to just 50 to 70% recovery rates from traditional recycling methods. And here's the truly shocking part. The entire process is carbon negative. The bacteria consume more CO2 during their metabolism than is produced by the recycling process. What we've just seen is the reality of waste management in 2025. From bacteria that breathe metals to engineered biological systems that turn poison into profit, we're witnessing a revolution that will forever change how we deal with the 50 million tons of battery waste produced every year. The question is no longer whether biological recycling will replace traditional methods, but how quickly it will happen, and whether we can scale this technology fast enough to save our planet from the toxic time bomb we've created. Which of these bacteria impressed you the most? Would you trust microscopic organisms to clean up our most dangerous waste? Let me know in the comments, and don't forget to subscribe for more content like this. See you in the next one.